This is AQA GCSE Chemistry. It's a Trilogy 2019 paper. It's a foundation tier question covering atomic structure, periodic table, and bonding. So pause as you go, have a go at the question first, and then review. Here is part A, part B, part C, part D, part E, and finally part F and G, an 8-mark question in total. So taking a look at part A, what is the ratio of metal A atoms to metal B atoms? So you're simply counting them up, and if you do that carefully, you'll see you've got 18 of the A's and 2 of the B's. Now that gets the mark, but we can obviously simplify that to 9 to 1. On to part B, what do we call a mixture of metals? This is a straightforward keyword definition question. That is the definition for an alloy. On to part C, a silicon sphere has a mass of 1 kilogram. The largest impurity in the silicon sphere is copper, and there are 7 by 10 to the minus 5 grams of copper in the silicon sphere. What is that in kilograms? Well, to convert from grams to kilograms, you will divide by 1,000. So 7 by 10 to the minus 5, divide by 1,000, goes to 7 by 10 to the minus 8. Part D, an atom of silicon has 14 electrons. You can also find that on your periodic table, mass number 14. What is the electronic structure? Well, we know that the first electron shell can only hold 2 electrons. That immediately disregards the final 2. So we're then left with 248 and 284. We know that we fill from the lowest energy level first and only move on to the next one when it's full. So that means that we're going to go 284 rather than 248. On to part E. Which 2 words describe the bonding in silicon dioxide? So silicon and oxygen are both non-metals, so that is covalent. And what we're then thinking is about descriptions of covalent bonds. Ionic and metallic are totally different bonding types. Intermolecular forces exist between molecular covalent atoms. But covalent bonds we will generally combine with the word strong. Silicon dioxide has a high melting point because there are lots of strong covalent bonds, therefore lots of energy needed to overcome them. For part F, how many silicon atoms are bonded to each oxygen in silicon dioxide using figure 2. So if we go back to figure 2, you can take a look at it and you can see that each is bonded to 2. And finally, for part G, which symbol represents the state of silicon dioxide at room temperature? Well, it is giant covalent, which means it is a solid, and the solid state symbol is an S in brackets. And that takes us to the end of this question.